Alright, so in this video we're going to cover the concepts of quartiles and how do we make box plots. Before getting into quartiles, let's talk about a percentile. So a percentile is a data value for which a given percentage of the remaining data values fall below that particular value. Okay, I know, not the cleanest definition, but you guys have experienced percentiles before. For example, if you scored in the 90th percentile of a standardized test, what this indicates is that you didn't necessarily score a 90 on your test. What it means is that whenever you're in the 90th percentile, whatever that score is, it's higher than 90% of everybody else who took that exam. That's what a percentile is. It gives you a percentage of people as the data value such that the percentile, the percentage below that is the percentage of people that scored below that test score. Okay, so how do we calculate percentiles? All right, so the first thing that you need to do is place your data in ascending order. That means going from least to greatest. And then to locate the position of your percentile, we're going to use the following formula. So we're going to find the index, that's the location. And it turns out that to find the index of your percentile, it's K, which represents the percentile that you're trying to find, times n plus 1, where n represents your number of data values, divided by 100. So once again, this I tells you the location of the percentile. And as I'm sure you guys are used to, if you remember back in the day when you guys talked about medians back in your middle school class maybe, you remember how if the index was a decimal, specifically a 0.5, remember you had to take the average of the two data values on either side? We're going to have to do something similar to that in a second. So here we go. For example, consider the following data values which represent the final exam scores of students. And so we're in luck because the data is already in ascending order. Okay, so the question is, what is the 50th percentile? And it turns out that the 50th percentile is the same thing as the median. Okay. Well, using that formula from before, I'm just going to rewrite it here for convenience. Remember, we said that I, the index, is equal to K times n plus 1 divided by 100. Okay? Well, K represents the percentile. So we're trying to find the 50th percentile, so our formula becomes 50 times n plus 1. N is the total number of data values. So if we were to count these up, you see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. We have 16 total data values. We have 16 total data values. So our formula becomes 15 times 16 plus 1 divided by 100. Okay? So basically it's 50 times 17 divided by 100. So let me go to my calculator, if I have that up. Let's do exactly that. Let's do, parentheses, 50 times 17, and that quantity needs to be divided by 100. And there we get 8.5. Okay. And so remember, I represents an index, a location. You can't be in 0.5 of a location. So what this indicates is that our percentile, the 50th percentile, is going to be the average of the 8th and the 9th position of our data set. Okay, so let's see that. Let's come from the left here. 1, 2, 3, 4, 5, 6, 7, 8. 88 is the 8th data value. 89 is the 9th data value. So therefore, our 50th percentile will be the average of 88 and 89. So you take 88, add to it 89, divide that by 2, and you're going to get 88.5. if you work out the math, okay? So the 50th percentile of our data set is 88.5. The median of the data set, which is the same thing as the 50th percentile, is 88.5. Okay. Now, the example I did here you had to do one extra step because our index was a decimal. If your index ends up being a whole number, then your percentile is just whatever that index indicates. All right, here we go. Same data set. Let's find the 90th percentile. Okay, once again, we're going to use our formula. I'll scroll down a second. So I is equal to k times n plus 1 over 100. So we know k, in this case, is going to be 90, because we're trying to find the 90th percentile. Still 16 plus 1, divided by 100. So 90 times 17 divided by 100. Let's see what that gets us. Not 1,000. Oh, man. Let's see here. 90 times 17 divided by 100. All right. In this case, we get 15.3. Once again, you're going to have to take the average, okay, of the two values around that. So what we're going to do is if we go back, okay, what was it, 15.3? So that means we are going to average the 15th and 16th position. Okay, so let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, and 16. So we're going to average 99 and 99. Well, you're going to get, so the 90th percentile is 99 plus 99 divided by 2. Well, the average of two of the same things is that same thing, 99. So the 90th percentile is 99. Okay. So quartiles, getting to the main topic of this lecture. Quartiles are just data values that are going to separate your data set into 4 equal parts. Well, quartiles are just really specific percentiles. Okay. The first quartile is your 25th percentile. The second quartile, which we denote Q2, is the 50th percentile, and we know that the 50th percentile from the previous example is the same thing as the median. And your third quartile is the 75th percentile. So if you want a visualization of what the quartiles are calculating, imagine that you have a literal block of data. Okay, you're going from least to greatest. The second quartile, Q2, is the median of the entire data set. Your first quartile is now, look at just that left half of the data set. If you take the median of just the left half of your data set, that is what the first quartile represents. And if you look at the median of just the right half of your data, past the median, the overall median, you're going to get the third quartile. And there you can see we have 4 equal blocks of data. But once again, to find the quartiles, it's just using the same formula we used before, just using those specific percentiles. Okay. For example, find the quartiles for our data set. Okay. So here we go. So Q1, which we know is the 25th percentile, we know that from this indicates that the index for this has to be located at the, let's see here, k times n plus 1. So 25 times 16 plus 1 divided by 100. So it's 25 times 17 divided by 100. Divided by 100. Okay, we got 4.25. And so what that means is we need to take the average of the 4th and the 5th position. 4th and 5th position. So let's see here. 4th position would be 79. 5th position would be 80. So Q1 equals, let's see here, 79 plus 80 divided by 2, which gives us a 79.5. So the first quartile, 79.5. The second quartile, I'm not going to redo the work because we've already done this. The second quartile is the 50th percentile, and we know that from before. What did we say? We said that the 50th percentile was 88.5. So 88.5. And then lastly, the third quartile, which is the 75th percentile, can be found by using the formula I equals, this time 75 times 16 plus 1, because it's the same data set, we have 16 data values, divided by 100. In this case, we get, let's see here. I'm going to do second, enter. I'm going to be a little lazy here. I'm going to just recall what we just did, just change the 25 to 75. We'll delete that. All right. Let me insert my parentheses. All right. So 75 times 17 divided by 100. We got 12.75. This is 12.75, which indicates we need to average the 12th and 13th position. 12th and 13th position. So let's see here, coming from the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 12 is 92. The 13th position is 93. So we need to average 92 and 93. And if you were to work that out, you're going to get a 92.5. Okay. So those are our quartiles. Q1, 79.5. Q2, 88.5. Q3, 92.5. Okay, trying to move along here. So when you have a data set, sometimes you just want a quick little synopsis of your data set. Well, one way you could do that is via something called the 5-number summary. So your 5-number summary just simply lists 5 values that summarize your data set. These 5 numbers are the minimum and your quartiles, your Q1, your Q2, and your Q3. Remember Q2, same thing as the median. And then also your maximum. So those are going to be your 5-number summary. So using the same data set we've been using so far, what's our 5-number summary? Well, the first number is our minimum, or our minimum data value is 39. Our second number is Q1. And if you remember, Q1 was 79.5. The third number of the 5-number summary is the Q2, or the median, and that was 88.5. The fourth number is your third quartile. I don't remember that. That was 92.5. And then finally, our 5th and final number, the 5-number summary, is the maximum, which happens to be 99. Okay? So, that's your 5-number summary. And what's actually kind of cool about the 5-number summary is that now we can actually use that to determine if a data value is an outlier. So I'm kind of jumping the gun a little bit, but an outlier is an extreme or a weird value. Well, how do you know if you're weird enough? Well, what we need to do is we need to compare that data value to the the middle 50% of our data set. And to do that, we're going to calculate something called the interquartile range. And the interquartile range is going to give you the range of the middle 50% of your data. And if you remember, Q3 is the 75th percentile. Q1 is the 25th percentile. So 75 minus 25 is 50. Therefore, the IQR is your third quartile, subtract away your first quartile. So for example, same data set. We know from before, we know that Q1 remember it's the second number in the 5-number summary, is 79.5. We know that Q3 is 92.5. Okay, so then the IQR, so the range of the middle 50% of the data, is 92.5. Subtract away 79.5, and you're going to get 13. 13 is your IQR. Okay, almost done. So the grand finale. How do we determine if a data value is an outlier? How do we determine if a data value is weird enough? Well, there's actually a mathematical way we could do this. All right, so determine if a data value is an outlier, we must determine what I like to refer to as the outlier interval. Okay, so what this interval is that you're going to have a lower bound and an upper bound within the interval. But the lower bound is found by you take your first quartile and you subtract away 1.5 times your IQR. That's your lower bound. Your upper bound is found by taking the third quartile and adding 1.5 times your IQR. So once you calculate these numbers, these bounds, then you're going to have to inspect each of your data values. And if you have any data values outside of this interval, then those data values are considered to be outliers. And there's no general rule that says that you have to have an outlier. It is possible for you to have a data set that has no outliers. It's possible to have a data set that has just one outlier. And it's also possible to have a data set that has multiple outliers. All depends on what the data values are. Okay, so here we go. Last example. So we have our same data set that we've been working with. The question is, are there any outliers in this data set? Well, look at all the data values. Do any of them kind of stick out as being unusually different from the bulk of the data values? That 39 seems pretty low, but we have to make sure that it's low enough. Okay, so to do that, all we need is our Q1, which was I believe the 79.5. Yep. Q1, if you recall, was 79.5. Q3 was 92.5. Excuse me. And our IQR, as we calculated earlier, was 13. Therefore, let's do a different color. Our outlier interval will be the following. We need to take Q1, 79.5, and subtract away 1.5 times the IQR of 13. That's going to give us our lower bound. Our upper bound is found by taking the Q3, 92.5, and adding 1.5 times that same IQR. All right, definitely need a calculator for this. So here we go. So let's clear this out. So I'm going to take 79.5. I'm going to subtract away 1.5 times 13. Okay, and the calculator is going to do the correct orders of operations. It's going to multiply first and then do the subtraction last. Okay, we do that, we get 60, and then I'm also going to do, so I can just do second enter. We are going to do 92.5 plus. Let's do that again. 92.5 plus 1.5 times the IQR of 13. Come on, 3, where you at? And we get 112. So 60 and 112 are the bounds of this interval. So this outlier interval goes between 60 and 112. So the question becomes, do we have any data values that are outside of that interval from 60 to 112? We do. That number 39 is outside of that interval. So do we have any outliers? Yes. Okay. 39 is an outlier. Okay. So once again, An outlier has to be outside of your calculated interval. All right, last one. This is the last one, I promise. Okay, so the last thing in this video here is how do we construct a box plot? So a box plot is simply a graphical representation of your 5-number summary. Okay, so the actual box that we're going to make in a second is represented by your quartiles. And then there's these things called whiskers that extend out from the box. And they are going to extend to your smallest and largest data value respectively. All right, so here we go. Let's once again copy down our 5-number summary here. So the minimum is 39. The Q1 was, what was it, 79.5, I believe. The median was 88.5, or Q2. The Q3 was 92.5, and the max is 99. Okay. So with that 5-number summary, this is what a box plot will look like. So I like to draw my box plots horizontal, but you can't have vertical box plots. There's no rule against those. And what I'm going to do is I'm going to indicate my scale here. So I'm going to go in increments of 10, I believe. So let's do 30, 40. Okay. And so here we go. Let's go different color. All right. So what I like to do is I like to indicate landmarks. Basically what I mean by that is that our Q1 occurs at 79.5. So 79.5 is really, really close to 80. So we're going to be here. Sorry, it's kind of hard to draw this. Our median, our Q2 is 88.5. So it's close to 90. And our, let's see here, our Q3 is 92.5, so just a little bit to the right of 90. And those 3 values, your quartiles, you're going to connect those, and that's what makes your box. It's really hard drawing on a tablet, y'all. All right, so that is our box. It's like a 3rd grader drew that. So the left side of the box is your Q1, the middle is your median, your Q2, and then the right side is your Q3. And then next what we're going to do is we're going to draw whiskers. So our smallest data value is 39. So 39 is way over here. So we're going to extend a whisker from that box all the way to that 39. And also we're going to do that for a maximum. Okay, we have a max of 99, that's just shy of a 100. We're going to extend a line out to that. So there you go. If you have a box plot, you should be able to look at it and be able to tell what the minimum is, what the Q1 is, what the Q2, Q3 is, and also what's the maximum data value. All right, see you guys in the next video.